Hey, morning, guys. I'm going to just go through a couple quick examples here. So yesterday we learned about the parent functions for sine and cosine, and today we're going to transform them just in a couple different ways. As you can see here, there's really four different ways that we're going to focus on. Okay, but today we're just going to focus on the A and the B. Okay, the C and the D is what moves the graph left, right, up, down. We'll work on that tomorrow. Okay, so here's what the A does. Okay, so think about it. If you have a number outside of the function, in front of the function, typically what that does is it vertically stretches or shrinks the graph. So what that's going to do is affect the amplitude of the graph. So whatever we see in front of the function ends up being the amplitude. The only thing is, the reason I have the absolute value there is because if A is negative, it doesn't affect the amplitude. That does a reflection. Okay, so really A can do multiple things. All right, and then B, which you guys can see here, after the sine or cosine for that matter, that horizontally stretches or shrinks the graph. So what that's going to do is it's going to affect the period. Okay, and remember when something is affecting the x, or in this case the theta, it has kind of the reverse effect you might think. That's why the formula for the period is 2 pi divided by b, even though it looks like b is multiplying by theta or x or whatever it is. Okay, it could be either. All right. So anyhow, we'll do two examples here and we'll take a look at that. All right, so here's what we have. We have a negative 2 for our A value. Okay, if A is negative 2, that means two things are happening. Okay, we have a reflection, so the sign will be upside down. And then we also have a stretch, so the amplitude is 2. All right, amplitude is always positive, so just leave that as 2. And by the way, we're only going to graph one period here. Okay, sorry, I forgot to change that in directions. Last year we did 2. We're gonna get it down to 1 period. Okay. But the period, remember, the period is affected by this 1/4 right here. That's the B value, okay? And what we're going to do is we're going to take 2 pi and divide by that 1/4. Okay, that's the formula. It has the reverse effect you might think. So instead of multiplying by a fourth, we're going to divide by a fourth. And dividing by a fourth is the same as multiplying by 4, okay? So our period is 8 pi. Now remember yesterday we talked about dividing each period up into 4 pieces. And the 4 pieces represent the 4 quadrants. So to figure out how far apart the tick marks are, you just take that period and divide by 4. So it should make sense, I think, that if we're going to go all the way to 8 pi, because that's how long the period is now, because it's been stretched out, that when we divide it into 4 pieces, 2 pi, 4 pi, 6 pi, 8 pi, kind of makes sense, right? So yesterday we went up to 2 pi. Today we're going to 8 pi because we've had it horizontally stretched out, all right? Now, not only that, we're also going to go up to 2 and down to negative 2 because it's been vertically stretched out as well by that A value. Okay, so we've got our tick marks built. And again, we're only going to graph one period. Sorry about that. I didn't change the directions, okay? But what we're going to do now is sketch the curve. And when we do that, we have to consider the fact that we have this reflection, okay? So remember what we said yesterday. Let me change colors here. That sine always starts in the middle because the sine of 0 is 0. We'll start right there in the middle. All right, now, yesterday we talked about the fact that the graph goes up first and down second because sine is positive in the first 2 quadrants. But guys, remember, we have this reflection here. So first we're actually going to go down to negative 2, and then we'll go up to 2. It's the reverse of what we did yesterday because of that reflection. Oh, geez, my pen won't work. There we go. All right. So that is what a reflected sine graph looks like. Instead of going up first and down second, it's going down first and up second, okay? So we had a stretch vertically that changed our amplitude to 2. We had a stretch horizontally, which changed our period to 8 pi, which in turn changed our tick marks. And then we had that reflection, okay? All right, let's do one more. All right, so this is a cosine. Now this time A is positive 3, so we have no reflection, but that amplitude is going to change. B is 2. Okay, so B is 2 means we're going to change the period, and we're going to take 2 pi and divide by 2. Remember, that's the formula. And it, again, it has any value that's affecting the x or the theta has the reverse effect you might think. So it might seem like it's times 2, but it's actually dividing by 2, so our period is only pi. Our period is getting cut in half. And because of that, remember what I said, take the period and divide it by 4 to get your 4 tick mark. So now instead of us going up to 2 pi like we did yesterday, we're only going to pi. And because of that, we're just going to go pi over 4. And then think about it, 2 pi over 4s would be pi over 2, then 3 pi over 4, then pi. So we've broken pi up into 4 chunks. Now we have to go up to 3 and down to negative 3 because our amplitude has changed, right? Okay, so now let me change colors. Remember yesterday we said that cosine starts up at 1 at the maximum. Well, now that our amplitude has changed, this cosine is actually going to start up at 3. It's going to start at whatever the maximum is, guys, okay? Whatever the maximum is, so 3. And then it's going to come down here. Remember, it's positive in the first quadrant. And then down here and here. Remember, it's negative in quadrants 2 and 3. Then come back up. And there we go. That's what we have. We're only doing one period, just to the right, okay? So really, we just need to remember what the shapes of the graphs are. We need to know how the amplitude is changing, the period is changing, and the tick marks. And then you have to know also, in case I reflect it, what we do. Okay, now we didn't see in these examples a negative cosine, but just as a quick side note, if we did have a reflected cosine, it would have started down here at the minimum and then gone up. Okay, so anyhow, that's kind of how things go here. Hopefully that makes some sense, and you guys are going to do some practice problems, okay? I probably forgot to change the directions on the homework too, so just do one period on the homework as well. All right, guys, have a great day.